All right, so let's see. So homework 6, I graded and posted feedback last night, and homework 6 looks good. So the really good news is it looks like most people understand how to do state machine synthesis, which is fantastic, because this is not an easy topic. It's got a lot of parts and pieces and a lot of steps to it, and most people seem to be on the right track with coming up with a machine to implement, a diagram like this. The only downside is a lot of people were getting tripped up by the K-maps, and that's good as far as the state machine, because the state machine part is what we're working on right now. But it looks like there's still some confusion about how to do K-maps, and so let me just mention a few things that I saw. First of all, it's really helpful if you work methodically. So, for example, after you've got your state diagram and you're trying to minimize an equation for, say, J0, right? It's useful if you label your K-map J0 and label what the rows and columns of that K-map are, and then label these with the bit pattern. Right, so that somebody looking at this can tell this is the minimization for J0, and here's the values of Q1, Q0, so that if you don't come up with the right equation, right, I can tell if you put things in the wrong order or things like that. So for J0, it looks like this is a 0, 1, 1, 1, and everything else was a don't care. So that's the first thing, is just working methodically. Not going across the page, right? But work from top to bottom. Label everything that you're doing, and try to keep everything in the same order. So if you're trying to minimize a truth table, ideally first you have the truth table, and then you have the K-map that you're using to minimize it, and then you have the equations that you got from the K-map, so that following your work goes in the same order from top to bottom that you did the work in. And then as far as the actual mechanics of the K-map, remember your rectangles have to be either 1, 2, or 4 on a side. You can't do, for example, a 3 by 2. It's just not a valid covering, and there's no valid way to write an equation corresponding to that. But you can do 2 by 2s and 1 by 4s and so on. The other thing that I saw some issue with was using the don't cares. So remember, don't cares are optional covers. Now, if we ignore the don't cares, then we're going to get one rectangle here, that's a 1 by 2, and one here, which is a 2 by 1. That'll give us a cover, but we can do a lot better. Because if we take advantage of these dashes, we can do a 2 by 2 to pick up those ones. And the equation for this, a 2 by 2, is going to simplify really nicely. So Q1 is a 0 or a 1. Q0 is definitely a 1. So we've got Q0, and then X can be a 0 or a 1. This is just Q0, which is a nice expression. And then we could also cover this one up here by actually picking up a whole 4 by 1. And in that case, Q0 can be 0 or 1. Q1 can be 0 or 1, but X has to be 1. And then if you put those together, you get a very simplified equation like that. Yeah, comment? Question? No?
I have a Tuesday.
Yeah.
So, unlike what you said, I didn't download the Aldec until now. Do I have to install, like, all 50 of those links?
No, so if you're doing the student edition download, you just want to install the student edition, and you don't need any device support. You just need the basic software.
Because it's telling me, it says all of them must be downloaded to install the tool. It gives me one thing called the main installation file, and then there's a bunch of FPGA vendor libraries.
Yeah, you don't need the vendor libraries.
Okay, sweet.
Yeah.
I'm having a problem as well, where I go to download it, but it wants me to sign in.
Yeah, you have to register for an account.
Yeah, it says it's still being processed, and it's been like over a day, so it's a little confusing.
So try it again, or try it with a different email address.
Okay.
Yeah.
We have at least 5 with all the schools.
Say again?
I'm sure most students have at least like 5 emails.
Yeah.
I know from
Probably.
middle school, high school, college.
And like I said, I tried doing this with my Clark address, and I got that same thing where it said it was processing it. And then I tried it from a different email address, and it came right through. So, but sometimes you just need to try it like more than once. Let's see. Okay, so covering the don't care is definitely make sure you use those dashes. Now, I didn't cover this dash. I don't need to, right? If it helps me, I'll go ahead and cover it. If it doesn't help me, I'm not going to spend another rectangle covering this, because that'll give me another term. So use them optionally to make your rectangles larger and fewer. That gives you a better cover. Don't ever cover the zeros, right? And it's probably less confusing to just not put in the zeros. Just put in the ones and the dashes, and then don't cover anything that doesn't have anything in the middle. Make sure you get the order of these things right. And the other thing I saw in a couple of cases was people were using a table like this to try to fill in the JK inputs. Make sure this table is correct. So in 2 cases, these last 2 entries were both -1, right? And this one has to be a -0. And what you're doing is you're saying you want to go from a 1 to a 1. So there's 2 ways to do that. You can either say 0, 0, don't change, or 1, 0, force the output to be a 1. And so that's a don't care and a 0 in that case. All right, I'm gonna mute everybody, but if you're trying to talk to me, go ahead and unmute, and you just use your microphone. All right, I think that was it for. Oh, the other thing is make sure you have a state assignment table, right? If you're filling out your state table and you're doing this kind of thing and there's an error in there, I don't know which state you're working from here. Is this state S00? Is it S01? And so on. Add a column that says, what's the name of my present state, with a name that matches your state diagram, right? Or have a table somewhere which says, for state S00, Q1 is 0, Q0 is 0. It may seem, unambiguous to you, but there are, a variety of ways that we can assign flip-flop values to different states. Now, if you stick to a standard like, list Q1 first and then Q0 and just use the subscript of the state name if they're named S subscript, right? But, that's a perfectly valid way to assign those 4 states to the values of 4 flip-flops. And you get just as valid a machine out of that on the end. But if you're doing this, right, then the mappings from present state to next state are going to be totally different. And so in some cases I was trying to figure out why your equations didn't look right, and I had to kind of reverse engineer what states you had. So make sure you list a state assignment table. I think that was it for issues, but again, like I say, the really good news is the state machine part, as far as understanding how this thing is moving from one state to another and so on, that all looked great. So as far as this part of the course, I think people are in good shape. But definitely don't forget what you've done with K-maps and truth tables and sum of products and so on. Got one product of sums in the design of the circuit, which was awesome because product of sums never gets uh, enough love from people, so that was good. All right, so any questions on that homework? Any questions on lab? Go ahead.
You only select the don't cares when it's beneficial.
Exactly, yeah.
You gotta think about it ahead of time a little bit.
Yeah, you can.
Okay.
You can try different things, and so it's nice if you fill in the K map in pen and then maybe the rectangles in pencil, because then you can erase and try different ones, and you'll get a feel for it pretty quickly. Mostly, I start by trying to cover the ones, and pick a one, maybe an outlier, and say I gotta cover that. What's the best way I can do it? If I pick this one right here, I've got a variety of ways to cover that, and I may not be sure what's going to be the best. But if I start with the ones that are kind of by themselves, and say what's the biggest rectangle I can use to cover this, that not only gives me a nice covering that includes that, but it also picks up this rectangle. This one right here, and then I've only got to cover this, and I can just say give me a big rectangle. So it's just a process, but you'll develop a knack for it the more you do it. All right, any questions on Lab 6? I've only had one person demo this so far, and remember, you've got to demo it to me to get full credit. So you want to hop into lab or office hours and show me your working Tinkercad circuit.
So we have to show it to you?
Yeah, you need to demo it.
I'm having lab hours Monday.
There's no school Monday. Monday's a holiday. So you got office hours tomorrow, office hours Tuesday, and lab hours Tuesday.
How many points will you lose if you don't have it demoed by then?
Oh, I don't know. I don't have an answer.
Does it matter if we do it on Tuesday?
You can do it on Tuesday, yeah.
Okay.
We'll lose points.
The lab's not due till Tuesday, right? Tuesday at noon.
Right, but if we demo it to you after noon.
I'd rather you didn't. I mean, I don't have hours after noon. So just plan on coming to office hours tomorrow or Tuesday, or lab hours on Tuesday.
I'm having a small problem. My computer is really crappy, and the circuit is so big that it'll freeze.
Really?
It'll freeze after 2 seconds.
So,
Oh,
Yeah.
So that.
Would you be okay with that?
Well, no, that's a really good thing to come into office hours and screen share and let me see what's going on, because the size of the circuit really shouldn't affect the load on your computer because it's being simulated, through a website and such. But if it's freezing after a few seconds, particularly with this circuit, it's possible that there's some kind of astable situation in the circuitry. It's in a state where the simulation can't decide if this is a 1 or a 0, for example. It could also be, that resources are being overwhelmed, but my first guess would be that it's possibly a problem with the circuit design itself, or the implementation of the design.
Okay.
And yeah, if you come in and screen share, that would work. And if you've been coming to office hours and working with me, you kind of know how this goes, right? You can get full credit for a circuit that does not work, but that's after you've shown me what's going on and you've discussed your attempts to resolve it, and then you write that up in your lab report. That's a valid part of a lab. And if it just doesn't work, or something like that, you can still get full credit. But the goal is, to go through the experiment and the procedures and have a plan and a schematic and try to implement it and record observations and write it up and discuss it. That's really the punchline here, right? Rather than, I built a traffic light controller. I mean, that's nice when it works, but that's not really the purpose, right? The purpose is the learning experience and the debugging experience and things like that. In my programming classes, I tell my students, and I'm not just being cutesy about it, it's a very sincere statement. The greatest thing that can happen to you when you're working on a program is it does not work. And you encounter a bug, and if it's a bug you cannot figure out what the problem is, that's a gold mine, right? That is the problem designed just for you to help you understand something that you don't understand. And those are priceless learning experiences. And I tell my students, don't ever just delete a program like that and start over. Because if you delete that, you've lost, the perfect homework problem that's going to teach you something you need to learn. So don't think of this as like, my light didn't blink, I failed. Let's look at what you're doing and figure out why the light isn't blinking, right? And that's a success. So that sounds corny, but it's true, I swear.
I have another question about the, so since I work up to lab, is that fine? One of these points?
What do you mean you work up till lab?
Like, I won't be able to show you it before, like, 12?
So I've told people that I can make arrangements to meet outside of the regular hours, but we have to set that up ahead of time. And so send me an email and propose a date and time, and we can try to find a place when we can Zoom together and you can screen share and such.
Okay, cool, thank you.
Yeah, you're welcome.
I have a question.
Yeah.
It's about the write-up on experiment 1 of the lab, and it's not very specific about what it wants. It just says create this part of the circuit. What kind of, I don't know, write-up do you want for that kind of thing? Because I know it needs some sort of write-up system and explanation for it, but it's not asking for it.
So it says design and implement a 2 to 4 second delay, that one?
Yes.
Okay, so the boilerplate stuff, right? For each experiment, include problem statement, specify items given and to be found, answer experiment questions, schematics, simulation, etc. So you can do all of that, right? So experiment 1, we are designing and implementing a 2 to 4 second delay using this and that. The 555 has been configured to generate a 2-second pulse using this circuit. Show a picture of the circuit, right? So someone else can reproduce. And then what did you do with that? How did you hook it up to that other chip? Well, presumably you set up that chip to act like a D flip-flop feeding another D flip-flop. You had the clock feeding the first input, the output of the first feeding the second output of the second is the output of your circuit. So have a circuit diagram for that, right? And a sentence, explaining what it does. Show the fact that you had to set the set and clear inputs to 5 volts. And so you connected those, through a resistor to VCC. And then how did you test this circuit? So what I suggested was hook a switch up to the first input, hook an LED to the output, and then observe that when you flip the switch to where it's generating a logic 1, it takes a few seconds before the LED turns on. And then when you flip the switch to a logic 0, it takes a few seconds for the LED to turn off. So describe that experiment, describe the observations, what you saw happen there. And this is all, with the mindset that now somebody else can get the same components, build the same circuit using the schematic you provided, set up the 555 the way that you described, and do the same experiment. Turn the switch to generate a logic 1 and see that it takes a few seconds for the LED to come on. And then turn it off and wait a few seconds, right? So you're describing all of that that you've done and how you tested it and what you observed. That would be a great write-up for experiment 1. Does that make sense?
Yes, thank you.
Cool, welcome.
I just wasn't sure if you wanted like the whole 9 yards or if you just wanted a small explanation. But it sounds like the whole 9 yards.
Whole 9 yards is always good, yeah. All right, other questions? All right, well, let's play with Aldec. So, a couple of people just mentioned that they're having trouble with this, but presumably everybody else has downloaded this and installed it and gotten it to start. So let's play with this software in some detail. And as I warned you, this is pretty finicky software. So a couple of things around that. One, I've written up a set of instructions that if you follow them pretty precisely, you should be okay. If you miss a step or do a step slightly differently, it may not cause a problem. It may cause a small problem. It may cause everything else to fail. So you want to be prepared to sort of go back and start from the beginning. And your goal in working with the software, I think, up front, first goal is get through the whole process from beginning to end. And it might take 5 or 10 tries, okay? And you got to kind of be prepared for that. It may be, you know, you skipped a step and you'll go back and try to do that step and it's just not going to work. Close everything out, make a brand new workspace, start over again, okay? And try to at least one time get through the whole process from start to end in a way that makes sense to you. And it can be useful to, you know, sort of make your own notes that describe the steps with, you know, the things that you found really important to pay attention to and so on. But get through that process from start to end. Once you can do that with a really simple Verilog program, like, you know, building an AND gate or an OR gate, then you can use that to start working on the larger experiments leading up to the homework in the lab. But don't be trying to, you know, implement a traffic light controller in Verilog while you're simultaneously trying to figure out how to work the software. Because the software is its own kind of battle to figure out. So learn that and win that battle with a really simple test program, and then go on. Sorry?
Question for you.
Yeah.
Now, you said the step-by-step process is it the homework or in the lab?
So I'm pulling that up right now so I can answer without making it up.
Thanks.
Yeah. Let's see. So HDL Quick Start Guide is what we're going to use first. We're going to use that today, and that's going to get us through a basic hello world for Verilog. So making an OR gate or an AND gate. That's not what I wanted to do. All right. So like I say, presumably you've already done the download, and the download you can get to if you click on Lab 7 on Canvas. There's a link there for the student edition, so you can do that download. All right, so let's go ahead and run this. Now I'm living in a Linux world, so I have a different version of this, and I'm using the teacher's edition, which is like 100 years old and really kind of rudimentary. And the version that you download will be the latest version, so it'll be a little more modern. Yeah.
It's a cool emulator.
Yeah, it's nice when it works.
Is it normally not a Windows or a Linux program?
It's not a Linux program, it's a Windows program only. And it seems to think I'm running it already somewhere, so I'm going to have to do some fighting here for a minute. Most of this stuff, so for just doing Verilog development, yeah, it's not going to let me run it. For just doing Verilog development, there's a variety of tools that you can use for that. There's a system called Icarus, which I really like. it's open source, it's free, um, and you can design Verilog, compile it, simulate it, look at timing diagrams from it, and so on. I've used that in the past with this course, and it usually works pretty well. But the Aldec tool is a little nicer. It does a few things for you that that you don't get with something like Icarus. But in general, when you work with FPGAs, you're kind of at the mercy of some vendors' software, and because you're sort of, if you buy a FPGA from Xilinx, you're using Xilinx's software. If you buy an FPGA from Altera, you're using Altera's software. And so there's not a lot of competition in the software realm. And so bottom line, the software is really, really bad, right? It will be buggy. It will break. It'll get updated randomly, and the updates will break things. It will do one thing one day and something different the next day. You'll run it, and it will run for 24 hours before saying, internal error detected, please submit a bug report. Okay? The software side has kind of, from the beginning of this whole thing, been a real sort of nightmare. And so we get in the habit of, learning a particular way to get a piece of software to do what we needed to do, and then just kind of sticking with that. And that's going to be a theme with the Aldec software, assuming that I can get it to run. So let me try a few tricks here. There we go.
So, funny enough, my dad actually got a Cyclone 5 the other day,
Oh, cool.
and I was wondering, is there like an easy way to export code, say, the AND gate on the help sheet? If I wanted to export that and use maybe the Arduino headers on it, I'd be able to do that from Aldec, right?
Getting out to a particular physical device is tricky. And with the free version of the software, that's pretty hard to do. The version that we're using of Aldec is mainly geared towards simulation, and you can use the same software to write bit patterns that will program physical devices, but that's where those vendor files come from, and those usually cost money. Let's see if this worked. Hey, there we go. All right. So I understand that I may use this for educational purposes only, nothing commercial, etc., etc. I said okay. All right, so you run this and you get a window like this. Oh, this is not going to be a good day, is it? Even though I said that the software is flaky, it's usually not this flaky. So I have an extra challenge because I'm doing this under Linux. There we go. All right, so my license will expire at the end of this year. I have a free license, right? All right, so let's go through this. And one more time. All right. So first thing is this one-time setup. this is just something you have to do, or the simulation's not going to work. And you only have to do this once after you've installed the software. So you need to go to your Tools, Preferences, Simulation, Access to Design Objects. This is already turned on for me, but come down to Tools. Oh boy. I wonder if I need to be on a different window. Let me turn off my screen share a minute. So I did all of this yesterday and it worked fine, which means it could be getting into issues with Zoom or with the screen recording. Or just sunspot activity. Alright, let me start killing off some processes here. So this level of difficulty I'm having now is not something you should encounter. Like I say, I think this is peculiar to my setup. Alright, well, I'm going to kill my, my screen recording and see if that helps.